Hello everyone, this is Zweli from Open Wound Research, and welcome to today's live coding session where we will be cleaning some wound care data, or as I titled it today, Debriding Wound Care Data, cleaning out all the noise so that we can do a nice analysis, so pass it on to the next person. So a couple of things that we'll be doing today. The objective is to convert a disorganized data set to an organized data set and to then store it in a directly human readable form, such as an Excel file, and a better non-human readable form, a Parquet file. Parquet file is a tabular format that stores the data and makes it easy to read from software that can deal with tabular formats. So Parquet is a very efficient format, but most people will deal with an Excel file. So our tasks will be to load the Python libraries that we'll need to do the analysis, load the CSV file. We are going to clean the column whitespace and case. Then we're going to remove any empty columns. Then we're going to remove any empty rows. Then we're going to rename columns, fix column data types. When we're done with all of this, we will perform a sanity check just to make sure that everything we had done prior makes sense. Then we will go ahead and export the file to Excel and then save it as a Parquet file. All right, perfect. So we're going to go ahead and uncheck all of these because these are the steps we'll be going through. Now, today's data comes from an interesting study out of India on something called, and I hope I'm pronouncing this correctly, Pranic therapy. So the article is called Pranic Healing as a Complementary Therapy in Diabetic Foot Ulcer Management, a randomized, controlled, double-blind trial. It is found in the Global Advances in Integrative Medicine and Health. And so you can just Google this and you'll be able to find it on PubMed. And they even have a PDF available as well, so you have the full text. And what's really, really cool about what Nitar and all did was that they made the data available. So if you go ahead and scroll down, go down to associated data, you can see that they provide URLs of where the data is. And if you click in here, it'll take you to a figshare repo. We'll just go ahead and accept the cookies. And then it'll give you a quick preview of the data. And then if you scroll down a little bit farther, you can actually just go ahead and download the data. And you just click that, and the data is downloaded. Perfect. So we've already downloaded the data. So I'm going to fire up my IDE. An IDE is just an environment where you can run some code. We're going to, first step, get a new file going. So the file is going to be a Jupyter notebook. We'll add a second column, second cell. And then the first thing we have to do is to select our kernel. And basically a kernel is just an engine to run code. And so we have one that's set up for basic data science. So we'll just go ahead and choose that. So now our kernel is loaded. And the first thing that we have to do is to import the libraries that we'll be using. So today we'll just be using one library, which is Polars. And Polars is a data frame library. What this means, it's a library or a set of tools that allow you to work with tabular data. tabular data is like an Excel file, a CSV, and so Polars is a very efficient tool for doing that. In Python, Pandas is more popular, but Polars is the new kid on the block. It's about probably a year and a half old. I use it because I prefer the syntax and the grammar of the library over Pandas, and it's also more performant. But you can do this in Pandas; you'll be perfectly fine. And if you know how to write Polars, you can write Pandas, and vice versa. So the skills are somewhat exchangeable. So the first thing we're going to do after we've loaded the libraries, which will mark as done here, we are going to head over to the next cell here. We're going to create a variable with the file path in it. So the file is in the same directory, so it should pop up here. Actually, it wants us to save it. So we'll go ahead and we'll call it Pranic study data cleaning. Okay. So we'll just have to choose our kernel again and just hit run all. So we've loaded our library. So I'll annotate here, load the Python library. Which we've done. Then we will create a variable with the file path. Perfect. So I'm just annotating it just to make things a little bit more understandable. And then we will make a call to Polars. We will then call the read CSV command. And then we'll pass in the path for the CSV. Oh, well, I should name it the right thing. That would be helpful. And there we go. We've loaded the file. So let's give this a name. We'll call it data. We'll do some bracket wrapping here, and this will allow us to indent this in an organized way. I like organizing things this way. It makes it easier to follow. Perfect. So let's complete our load CSV. So we've gone ahead and we've loaded the CSV. We have the data in front of us. Now, the one thing I want to do here is to increase the length of data we can see. It's cutting off some data. So if I go ahead and call Polars config namespace, and then there should be a command that will allow me to increase the number of rows. Yep, so we'll increase the number of rows to 100. And now we can see all the data. So if we look at the data, it's a lot of null values, which means empty cells. And this is a little awkward to look at in this aspect ratio because of the live casting. So what I did earlier was that I took a screenshot of just passing in the CSV file, which is the text file with the study information, into Excel. And so when you do that, you can take a screenshot and it'll give you this data small enough to be viewed on one screen easily. So as we can see, we have the different columns representing the data. We have part number, which is the subject ID, whether it was in this column here, which is whether or not they were in the interventional group or the control group. Defo is whether or not the ulceration was on a deformity or not. Gender is self-explanatory. Age is self-explanatory. Whether or not they were on insulin, which is a binary outcome, whether they had a heart condition or not, whether they were varicose or not. Dia since is the days since. I believe this refers to their time of participation in the trial or observed participation in the trial. You have FPBS on day 1 and FBBS at the end. It looks like they only collected data on 2 participants and they're null everywhere else. I don't think they use this in the final write-up. Then they have the A1C fasting on day 1 and on day 35 at the end of the study. Then they do a calculated column, which is the percentage change. Okay. And then they have some calculation here, which is unnamed. I think this is the absolute change in A1C. I think that is correct. Yep, that is the absolute change in A1C. Then you have this column that is marked here. I believe from reading the paper, this is the Wagner grade. And on day 1 of the study. And then the Wagner grade on the final day of the study. And then whether it improved or not. Then you have the monofilament test. SQ means status quo. Worse obviously means worse, and improved. And then do we have a null value? Yes, we have a null value for subject 24. Then here you have the vibratory perception test, which you can see from the key here. Status quo, improved, worsened. And then we have the wound area on day 1 and the wound area at the end of the study, which was between day 35 and 40. Then here you have the absolute change. And then here is the percentage change. Now what's interesting is that some of the values, like for example here 6.45 to 0, should be complete closure or 100% change, but it's 62.58 there. So I'm not certain what that means. Regardless, we have another calculation here. And again, the percentage change, it's this is the, I believe, the absolute change. And then I believe we have the well-being score as well. It's not actually a score, it's just a status. And so I think the data is pretty self-explanatory for the most part. So we'll go ahead and start cleaning it. So the first thing we want to do is to deal with the columns. So a common issue when dealing with wound care data, so I'll just make a head call here, is that there's leading white space or trailing white space in the column name. This is very common when you create a CSV. So we're going to make a call just to see the column names. So we call data, which is the name of the data frame we have here, and then just an attribute, which is the columns, right? So now it prints the columns. We can already see a couple of issues here. There's an unnamed column, as we can see here, and it looks like it's totally empty. So we'll probably just drop that. We just are going to check if there's any leading or trailing white space. right there. You have trailing white space. You have leading white space here. So we're going to need to clean that up. It's never good to have leading or trailing white space. Just can mess up how your file names are called, whatever program you decide to use. So what we want to do is we are going to create a variable which will hold, we'll create a function actually. So we'll create a function called clean columns. And it's not really a function, it's a call to the polars expression is probably the best way to put it. So we're going to call all the columns. So I'm going to wrap this as well, because this will make it a little bit easier. So wrap this. So we're going to call polars. We're going to say all columns. We're going to make a call to a namespace called name. Then we're going to call a function called map. And then, so this here is just the namespace for a set of functions for a set of column functions. And then we're going to call the map function. And the map function takes a what's called a lambda expression. Or a lambda function is probably the best way to put it. And the lambda function we'll call lambda, which creates a function. We'll call that lambda call, right? And then we'll say on the column, let's strip white space. So there's a special function available to us that does exactly that. So that looks good. We'll call with columns. Actually, here we have to call a select statement. A select statement just returns a data frame with the function run. Returns exactly the same data, but the columns will change. So we'll go ahead and grab that expression. We'll pass the expression, clean columns, into the select statement, the polar select statement. So if we do that, the white space should be gone now. So varicose before had that space, and then there was leading space here. So now that I've run this, there we go, it's run. We've got the green check. We will check what's happened here. So immediately we can see this white space is gone for varicose, and the leading white space is gone as well. So it did exactly what we wanted it to do. There are a couple of other things that I'd like to change. So when working with in Python, even in R, it's just not good form to have, ticks or backspaces, backslashes or forward slashes or percentage signs or addition signs in the name of files. It's just never a good look. It can mess up your code. It can create errors that you don't expect. And you also don't want hyphens. So generally, you in Python would do underscores for white spaces in the middle or to replace these signs. And R, the convention is cap to capitalize, but we'll use the Python convention, which is to get rid of all these things and replace them with underscores. So we'll just extend this expression here to do exactly that. So we are going to first lowercase everything. So let me do lower, strip lower. We'll just organize it this way. So now I've changed everything to lowercase. Now we have to replace these characters. So we're going to go ahead and replace, call the replace function. So what happens is when you call the replace function, you take the thing you want to replace and you pass in what you want to replace it with. Okay? So in this case, we're going to replace it with an underscore. And there we go. Anywhere there was a /, it is now an underscore. Okay. The next thing that we want to change is the hyphen. So we'll just take the hyphen there, put it in the first position, and there we go. Those become hyphenated. Underscored, I should say. The other one I want to change is the empty white space. We want to definitely get rid of that in the middle of a word. It messes with certain functions. So empty white space. Then the next one is the addition sign. Perfect. All right, the addition sign is gone. And then I think the final one will be the ampersand, the @ sign, sorry. And let's see if we have any @ signs left. Actually, we don't want to replace that with anything. Okay. All right, that's much better. We're going to also get rename the some of the columns. So this is just an intermediary step for us to change that. Let me see. Okay, that looks good. So we've renamed that, we've passed in this dictionary, and it's performed this renaming that we wanted to do. All right. So let us mark clean white space in case. That's done. And now what we want to do is to remove empty columns and remove empty rows. Okay, so in order to remove empty columns, we can use a command called filter, which will filter based on what we tell the program. So we can choose a column on which to filter. So I think we can filter on the group CI column, and we'll see how that goes. So we can call, pardon me, with columns. So it's telling the program to, actually, we want filter first. So we're going to filter based on the CI column, which is this one. And what we want are all the rows I think, forget what this command is called. It is, I believe, actually I believe it was right, is null, right? So that should return all rows that are not null. Oh, so we have a little problem here. That row, even though in this file here it looks like it's empty, there's actually text proximal to that row in the original file. So we can't use that one, but we should be able to use the defo column. That should work. And when we do that, perfect. So now it's dropped all the rows except the rows that we actually need. So now we only have 28, which is perfect. So that worked pretty well. I also want to clean up some of these columns. So we have one column that has no name and is all empty. Then we have some strange columns at the end here, which has just two values here and is null otherwise, and then all null column here. And then is there any other column that we need to drop? Let's take a look. Duplicated. So we have 3, 4. And then where's duplicated 0? Ah, this one. Now this one looks fine. Has some null values, but we won't drop that. All right, so we're going to call the drop command. And we're going to pass in the 2 columns, actually 3 columns that we want to drop. So we want to drop the column that is an empty string. So that's the empty string there. Then we want to drop the column that's all null. And then we want to drop the column that only has 2 values and everything else is null. I think they were just working on that and then clean it up. Okay. Let's see what we did here. So it's asking, oh, we forgot to add that. So, perfect. We've dropped those columns. Actually looks very good. We'll take that down for a second. Right. So we've removed empty columns. We've removed empty rows. So let's mark that as done on our task list. Perfect. So the next step is to rename columns. So which columns shall we rename? So the rename function in Polars takes a dictionary. So we call that function. Have no values there. That's fine. We need mapping. So what we'll do here is we'll create a dictionary called rename column dictionary. And a dictionary is basically a value and a key pairing. So the first part is the column's old name. So here we have part number. Part number doesn't make much sense. It's really the subject ID, so we're going to go ahead and rename that to something that makes more sense. So subject ID, and then we're going to pass that dictionary into the rename command, and we're going to uncomment that. So now you can see that part number got renamed to the new value. And we're just going to keep doing that. Just set up a couple more here, just in case we need them. Perfect. So part number subject ID, C_I, kind of not clear what that's meant there. So we're going to change that to group because that's really the control and interventional group. So we'll do the group. So that's perfect. Defo, let's clarify that it's whether or not it's a deformity. Perfect. Gender's okay, age is okay, on insulin, heart conditions, that's good. DS since is days since. So we'll go ahead and we will just change that so to duration, because that's really what's meant. And then we actually we'll keep it as duration. Then we have FBPS day 1, FBBS at the end. I reviewed the study. I wasn't sure what was meant by these values. I don't think they were used in the final paper. So maybe what we should do is just drop it, because I don't believe it was used. I might be mistaken, but actually I shouldn't put it in the dictionary. I should just put it in the drop command. So we're going to go ahead and drop that and drop that. Perfect. Then the next, so this D1, D35 construction, I don't think it's good. It should be start and end. That is less ambiguous. So we'll do this. We'll do H1 fasting. Again, we kind of know it's fasting, so we will change it to something a little easier. So start, and then we'll go ahead and what do they call it here? D35. Perfect. And then this is a little ambiguous here. So what we'll do is we'll call it we'll take the percentage change, plug it in here. Oops. And then we'll call it and we put our comma there. Perfect. So that makes more sense here. And I believe this is the absolute change. Yep, that is the absolute change. So duplicated is the and instead of calling percent change, we'll call it absolute change. Perfect. This D1, D35 here, this is the Wagner pre and post. So we will create 2 key pair values. We're going to go so this will be Wagner pre, Wagner post, and then this one is D1, and this one is D35 underscore. It's getting there. It's getting there. Then so this is interesting here. It states Wagner, if the Wagner's improved or not. So we will call this imp no. But we'll rename it to Wagner status. And then we have the monofilament, the VIB, which is actually the VPT. I think that's a typo. So let's see. I don't see VPT anywhere else. So I think this refers to VPT. VIB, which is actually VP. Might be mistaken, but I think I am correct. So that'll rename that. Then we have the wound area, starting wound area. And then we can go ahead and rename that. So it doesn't like something I did here, so let's go back. It doesn't even like that. So let's see. Interesting. So let's see what we have here. So VIB, got it. So it should be VIB VPT. So folks, don't make that mistake. Make sure you don't typo your column name. So wound start area, wound, actually I'm going to rename that wound area start, wound area start, and then wound area end. And that will be this value here. Perfect. So we only have a couple more to go. So we have wound area end. This is the percent change, I believe. Let's see. So this looks like the absolute. Interesting. So this looks like it should be the absolute change, but there are some incorrect values in here. 7,4 to 60. But then this one here goes 0. So this value is wrong. If you just do the math of the 6.45 to 0, this is correct. Okay, so what we'll do is we'll rename this, and then we'll do a calculation ourselves. And then this is the percentage change. Then there's some well-being score here. I believe that's what that is. So let's take a quick look here. So let's rename these real quick. So I think this is wound area absolute change. We could rename it that way, or we could actually make it shorter by just saying wound abs change. That's clear enough. And then we could go ahead and just name that there. And then what do we have? That's wound percent change. So we'll just use a convention that we used above. And that's changed. And then we have these two values at the end. And I'm not sure. So there's well-being, and then there's looks like a well-being score change, but I'm not sure what it's based from. We'll go with that. So we have duplicated 2, so we'll call that well-being score, and we'll call that well-being change. Right, so we've renamed all the columns we've wanted to rename. So that looks far better. And I think we can go ahead and just shrink that so we have a little bit more space. Shrink that. And I think so you can fold the code so that it just looks a little bit neater and out of the way, but we'll expand that later. But for now, actually we can keep it open and just scroll down. So if we look at our task list, we want to rename the columns. That's done. Now we have to deal with the data types. So when you're dealing with data, you need to be very clear what the type of your data is. And the cool thing about polars is that they give you what the current data types are in each column. And a column can only have one data type. So you can't put a string with an integer with a float. That's just not good for data management. So you want to make sure that each of your columns have the correct data type and only one type of data type. So if we look at a subject ID, that is generally encoded as string. A good rule of thumb is that for string data, for subjects, you want to not have it look like it's an integer. So you want to pad that number so that it has 0, 1 instead of just 1, or 0, 0, 1. That's generally good thing to do. I like to pad it with 2 zeros, and that'll make sure that the sorting works fine and it is obvious that it's a string, not an integer. So I'm going to make a with column call, call the subject ID column, and then call the string namespace, and then there's a function called zfill, and it just fills the leading values with zeros if it's less than a certain amount. So now it went from just 1 to 0, 0, 1. And now it is unambiguous that this is a string. And when you do sorting or anything of that sort, it will sort in the correct way. All right. So the next thing that we want to look at is the group. So we could stay with the intervention and control group, but I'm going to use the wound care convention, which is to call it PL group. Then we are going to call replace. Then we're going to add a dictionary. So if it is I, we're going to call that treatment. And then if it is C, the control, we'll call it SOC. Perfect. That looks far better. And then for deformity, on insulin, heart conditions, and very gross, those are actually binary outcomes. So it's 1, 0, or yes, no. So it'd probably be a good thing for us to clean that up. So let's actually, to make things look a little bit better down here, we're going to create variables that will hold our expressions. So we are going to call this zfill columns. Then the next one is rename groups. And then all we're going to do is just copy over what we wrote down here. And it just makes things look a little cleaner. So with columns, there we go. We pass in these variables that hold our expressions, and we get the same result. And then the next thing we're going to do is we are going to call deformity on insulin and hard conditions. Actually, we can actually do all of that with varicose as well. And then is there another binary? Yes, no. I don't think so. No, there isn't. So I think we've got all of them. So we can see another problem here. The casing on some of the yeses is capital Y. I think I saw one or two. Actually, it's a capital N. That'll throw off our mapping. So what we have to do is to make sure that everything is in the lowercase. So remember, this no here is capitalized. So what we're going to do is to tell the function that we called 3 columns, deformity on insulin, varicose. Actually, where's my hard conditions? Yep, there's hard conditions. We're going to tell it to put that to lowercase. So everything's in lowercase now. Let's see if we have any white space. And actually, now that I think of it, we should have called an all to... Actually, we don't need to do that. To check for stripping. I think we're good. So now that we've parsed everything, probably a good thing to do is to strip any white space. So we have the strip chars function. I don't know if there are any of these values that have white space, but it's cheap to just put it in. And then the next thing we are going to do now is to call replace, like we did before. We pass in the dictionary. If it is no, that is false. And if it yes, that is true. And great. Now it's flipped from yes, no to true, false, which is binary outcome. So it's a little cleaner. And if we put this into a working pipeline, it'll just work more efficiently than if it were a string. But I do notice that it is storing it as a string, but we want it as a Boolean. So cost. So we're going to change the data type to Boolean. So casting from UTF-1 to Boolean not supported. Okay, so what we need to actually do then is to rewrite true false from string to 0, 1. And then I believe the problem is we have to first cast it to an integer, a numeric value, then to a Boolean. Yes, so there we go. So now we have the correct data type, and it is true false. That is a very long expression, so what we're going to do is we are going to call this convert to Boolean. Then we're going to copy all this code, which is very unreadable. Then what we'll do, just so that it's easier to follow, is we're going to wrap it so that we can fold it. So here we will segment each of our string calls. And as you can see, it's far easier to read when you fold it like this. So we call the columns that we want to do the action on. We call the string namespace and we make it all lowercase. We strip the white space. We replace the no's and yeses with 0, 1s. We convert it to an integer data type, and then we convert it to a Boolean data type. And there we go. So that looks good to me. We could encode this as categorical, but I think for purposes of this demonstration, I'm not going to do that. I'm going to keep this as is. So it's just a little bit more readable. We then have duration, which is actually not a string. It is an integer, i.e. the number of days. So we just have to find columns that are all integers. So it looks like duration is an integer. Wagner is actually an integer as well. Well, we could keep it as a string, technically, because it is referring to an ordinal variable. So we'll actually not make that an integer. That would be mixing data types. So we only have really one integer. So we will say convert to integer, and that's pretty simple. PL call, the column name is duration, and we're going to cast it or change it to an integer 16 because it's a small number, so we don't need to use an integer 32 or 64. Then we just simply copy and paste that there, and we can see that it is now an integer 16 with a fixed data type, and that's perfect. Now, you're in the A1C, we have a string and we have a float. So the program kind of chose what it was going to do. I think what we should do is add a call when we read the CSV where we tell it not to infer the data type. So infer schema length equals 0. So what happens is when you read in the CSV, the program will attempt to read all the columns and guess what the data types are. I did not notice or remember at the start when we began, but we could change that behavior by just saying infer schema length 0. So now everything will be a string so that it doesn't change the data type. So you can see everything's a string now, and it isn't mixing and matching. So the A1C is actually a percentage, which is a form of a float. So let's see. That's a percentage, that's a percentage. Ironically, that's a percentage as well. So we're going to pass in all these columns, and we're going to treat them as percentages or floats. And then the absolute change is also a float. But this year we'll have to do some cleaning on the percentage column because it's represented here out of 100, but the convention we should be using is 0.116, not 11.6. So let's go ahead and let's add space between here and here, just keep ourselves organized. And then we'll convert to float. We will call all the columns. So we have start, what's this, start, end, and change. And then we'll do our usual folding here. Or indentation rather. And then we'll just take a look at the data. So we have no strange symbols. Things are fairly consistent, and null just means there's no value. And then we have some negative values, but floats can take negative values, so that shouldn't be a problem. Actually, the absolute change we should also add here. Perfect. And then all we have to do now is call cost, PL float. I believe float 32 should work. And then we add it to our with column statement. And now we have, can I choose a smaller float? I do not believe float 16 exists. Yep, we get an error when we try to pass in a float 16. The smallest float is a 32. Great. Maybe what we do here as well is just round to 2 places. Will it allow us to do that? Okay, so floats are stored in a certain manner. When we do an analysis, it will take it down to the right number. It's just that floats are stored with more spaces than needed. It's a little quirk in Python. Let's see. So we have these columns that are now all floats. I believe there's more floats at the end here. Yes, there are. So let's take a look at these. So no strange characters. Everything looks good. Great. So technically I should be able to do the well-being, but I might do that separately because of this percentage here and here. So what we'll do is we're going to pass this in. more. Great. And now we have our values. Again, don't mind the trailing numbers, just how it's stored in the data frame. You can hit call round 0.2 and you'll get those values on output. And again, it's just a way that Python deals with floats. So that looks fine. We should actually be able to, let's see. So if I call a replace first, so replace, so if I say replace the percentage with nothing and go back and check this, and we should be able to pass in the well-being score now. Let's see, conversion string for 1 out of 2 values. So why is that not taking? So we placed in, so maybe I have to add a regex to it. So it simply does not like that. We'll have to figure out how to deal with that percentage. So we'll have to deal with those columns by themselves. So that all looks good. Let's deal with this well-being score. Fix well-being score. PL call well-being score. And then, oh, of course, I think I know what I did wrong up here. We didn't call a namespace. So we string replace calls a namespace. Now we should be able to do it. And then we could just add in and that worked. Fantastic. We forgot to pass in the string namespace. So whenever we call these functions for strings, we have to pass in the string namespace. There's another function outside of the string namespace that applies to the data frame, and you'll get an error, as I did when you try to run that. Let's see. So there's a couple of other things we need to clean up here. So let's go back to A1C and let's do Wagner. I'm actually fine with Wagner. That's a string. And what we might do here is apply this here should be null. And we have to fix this value here as well. And then the other thing we should probably do is we have two choices. We can keep this as is, as a string, or we can, like we did with the subject ID, z-fill it so that it's O1 and O2. What I'll do here, and again, this is stylistic, we will keep it as is, but it looks like it's an integer. And that can be very confusing. Actually, we'll z-fill it. Let's do that. So let's deal with the Wagners. So we'll change this to fix Wagner. We'll call it fix Wagner. Has a bit of ring to it. So we'll do pass in Wagner pre and Wagner post. A couple of house cleaning things we need to do. We need to replace there's a new function called replace any. I'm not going to use it here. It's more efficient, but because I want to share how this works, we'll use the more verbose, clearer function. So ref will replace that. Actually, this is an interesting case. We cannot do that because we want to replace all the values and not just part of the values. And we don't know what these NA values are or this ref value is. So we're going to have to use a new construction, which is the PL when then construction. So this is a case statement. So PL when then otherwise, and then we have to call alias. And unfortunately, that means we can only call it on one column at a time. So let's do this. And this will just make it easier to follow. And then we should really say fix pre. In this first column, this first one here, there's actually no issues. We're going to leave it as is. So really this is fix post. And then what we want to say is when the column Wagner post, so when PL column Wagner post is in the set or contains the set of values, now we might get an error because we have these inverted quotation marks. So this might take, it might not. We might have to do a little bit of cleanup. So basically when PL call the value of the post here is in these two values, contains these two values, then we want it to be null. Otherwise, we just want it to be what was in the column before. Cannot create for type null. Okay, so we'll just say none. Perfect. All right, so where was I? Yeah. All right, so now we can go ahead and pass that in there. Interesting. So fix Wagner post. So did I mix pre and post? Interesting. So it is taking post. I see what it's doing. It's writing to the wrong column. Now it should work. So what I was doing, I had the wrong column that it had to write to, and it was writing to the preceding column, which is why we saw those values change in the pre. So now I can paste in this statement. So this href is, as I suspected, it doesn't error out, but it's not performing the function. So I believe I need to put an escape. Actually, let's try a regex R. That doesn't work. The other thing we can try to do here is backslash. That doesn't work either. So when working with this kind of data, it can be incredibly frustrating. It doesn't like that either. So how do we deal with this specific issue? Perhaps if we do something like that. Okay, so we're going to need to play around a little bit. So what we'll do is we'll do a return the first 10. Perfect. And then let's try to filter and see if we can find a way that will filter the Wagner post such that it returns just the specific item. So we'll call plit, and now we can actually it should just be this. I don't know why I made this difficult. Of course it is. Okay, so I've made it far more complicated than it needed to be. We'll actually, that's what I did put down. Interesting. So that's exactly what we have here, I believe. Perfect. That ref value is gone now. All right. Figured that out quicker than I thought we would. So let's continue. So we've cleaned the Wagner post. We have some null values, which is what we expect, but the data is otherwise good. Wagner post status. So here we have to map this to represent these values a little bit better. So this was improvement no before, so we're going to do a little bit of mapping. So fix Wagner post status equals PL call Wagner post status, replace parse out dictionary in yes with did it improved, and then SQ is no change. and then none is declined. Let's pass that into this function here. Column not found. There we go. And it should work correctly now. Perfect. So there are the changes we made. That's far better. Easier to understand. Then we have the mono and VPT, which are very similar to each other, so we can stick them in one function. So we can fix mono VPT. And actually, I believe there's one. Interesting. So we have all sorts of stuff going on here. So we're going to have to lowercase okay. So we have NAs, which are not applicable. So is the NA null or not applicable? We'll treat them as null, I believe. So mono, VPT, and well-being, we're going to have to do, because these have to be changed to null, we'll do a change here across well-being score as well. So well-being, and then what we'll do is PL when, then otherwise. So we've got the setup, which is good. So what we'll do is we'll say what PL call mono has this NA. Actually, we can't construct it that way. We can only do one column. So we'll do this. I'm sure there's a function that I could use, but I don't call it in real time here. But we're going to have to construct it this way to get it to work. Actually, we'll use this is some more flexible construction. NA, then none. Otherwise, pure mono. add another with, excuse me, with column, and let's see. Did it take the command? No, it did not. So let's see. Oh, we did alias. There we go. That's taking care of business. And then while we're doing that, we're gonna lowercase that. Perfect. Then we are going to run our replace. So we pass in the dictionary. SQ is no change. IMPR is improved. And we should actually do a strip here. Strip chars. Perfect. And let's go over and take a look at our work. So it's made the changes. The NAs are null. That's good. No change. Worse. I'm not sure if those NAs are actually NAs or null. I might be wrong, but I'm going to treat them as null for now. So let's go back up. This is improved. And then those NAs. Got it. So those should be not to none. So no change. So it should be worsened actually. So no, these are definitely null. Okay, so we'll continue to treat that as null. That makes sense. And then we will continue here for the VPT. This is great because all we have to do is change this line here, refer to the VPT column. There we go. And the VPT down here. And that should be good to go. Yes, it is. Now it's interesting, they're on some values that are null, obviously, which means they didn't do the test. That's interesting. Though not unexpected. So the next thing we have to do is just do this for well-being change. I think we will have completed this part of our task. So what do we have? Great. Actually, we'll just do that. And then we just have to change this value and this value and this value to well-being. Change. And we should be good to go. Perfect. So we have Interesting. So here we have IMP, which is not mapping. So we just have to include IMP. Actually, let's check something before we do that. Does this take regex? It does not. Okay. That would have been great. Let's check that again. I think I realized what I did. And then change this. Oh, still the case. I'll just change this here. Because what they've done is use two different values for improve, IMPR and IMP, which is messing with the there we go. So everything looks great, except I do want to fix these percentage values. Let's see. Actually, you know what? We'll leave this as is. It's more of a stylistic change, but I think this is fine. But I think this data frame is good to go. And let's take a look at what we have. So let's do a quick sanity check here. Our subject IDs look good. Group deformity. Seems to be that my true-false statement changed. Convert to Boolean. Yes, we did not. Name group convert. So we did not put our Boolean. There we go. I knew that that did not look right. So now we have our Boolean values back. Our group, gender, duration, looks good. Everything looks really, really good. The only question I have is around these percent change values here, which I think I can't help myself. I think we need to fix that. And so we calculate percent change, which is just okay, because that is across two columns, we'll do it this way. It is PL call. It is the new value. So that would be, actually the first thing I should do is fix the absolute change, because that doesn't look right either. So calculate wound absolute change equals PL call, the end area less the start area. We can add this to the columns column. Oh, of course. We have to tell it where to put it. Otherwise, it will go nowhere. So there's the absolute wound change, which makes far better sense now. These values look correct. And then the other, what is the so the percentage change is what we need to do next. And we can actually take the new, so that we can actually take this and just divide it by the start area. I believe this will work. Actually, we want that to be the percent change. Of course, I can't pass it in because it is set up as a variable. This is a technical thing, but since I stated the expression as a variable, I can't pass it from something else to something else because it has not run yet. So, not a big deal. We will do this. And the only thing we have to do then is to divide it by the old start area. And that should give us a percentage change. That is not correct. Okay, let's take a look. So I believe we have to wrap this here. So what is wrong with the formula? So the sub and the divide by that looks correct. Well, let's try flipping it. That is absolutely not correct. Yeah, so we get infinity. I see. Okay, it was correct. I just put it in the wrong place. So, wound, start, calculate. So I actually created a column that made no sense in the back here. I actually have to call it by the correct column. And yes, 100%. So the formula was correct. I just named it with the function and it created a column with that function name with the correct value. But if you look here, 100% different, so it's minus 100%. And then you'll see with 0 values, you're getting that as well. And then if it increased in value, in size, you get that as well. So we fixed the absolute value calculation. Let's see if these look correct as well. You know what we're going to do? We're going to fix these values too. So calculate. The great thing is we could just reuse these calculations. And percent change, absolute percent change. So we will go start, then end, and end. Then we just have to type in the correct column names. That's the absolute change. That is the percentage change. We pass this back into year, and we should be good to go. Interesting. So, percentage, absolute. It's possible to return same default name is new to avoid duplicate name. Okay. So interesting. I see. We did not pass the correct names here, so we just have to rename wound and then just pass in the correct name. And there we go. Right, quick sanity check. 12.3 to 10.9 is negative 11. That looks right. We see that that's risen by 6%. Great. So this looks better than our original data set, which looked like this. Far cleaner, far more organized. No null columns, no null rows. All the data types make sense. We've got booleans where they're supposed to be booleans, integers that are where it's supposed to be integers, and floats where it's supposed to be floats. We have recalculated the absolute wound changes and the percentage wound change, as well as the A1C absolute and percent change. And I think this data is good to go. So we'll just take a glimpse at the data. So there's 28 rows. All the data looks good when we glimpse at it like this. We have our data types, our column name, our data type, and some additional values. Looks great. We can take a look and test. So if we wanted to know call group dot value counts, there's 13 in the treatment group, 15 in the SOC group, so that stat works just fine. We can look at the deformity. 25 people had no deformities, 3 had deformities. The gender, 24 males, 4 females. Age, whoops. Age, we can look at the mean. Oh, age, this is great. We caught this. So age should be an integer. So let's go back and find our integer. And make it duration and age. And so our age now let's see. Convert to integer. So the question is, why do we have that convert to integer? Yes. And our age is now an integer. So great. So now this function should run 58.5. That's great. We can summarize the data one more way. So we can melt. Actually, we can melt it. Actually, the new command is unpivot. Index equals, and this is like a pivot table or the opposite of a pivot table. So group great. Index group. We can then believe we can run a couple of different things. But prior to that, I have to drop. So I believe we can so we go group variable, and then we can call an aggregation function, pl call val. Oh, I know what I'm doing wrong. Well, why don't we do this? Why don't we complete the session? That's outside of the specification of what we're talking about. But once you have this data, you can run aggregations and everything you wish to do and can do in Excel, but you could also do it in Python with the added benefit of it being fully reproducible, easier to do in a sense. And if you update your data, you don't get a lot of the issues that come out of Excel, where it changes your formats, drops things. There are famous cases of files being not well treated by Excel. So let's complete our last two tasks, which is to write an Excel file. We will call it Pranic study data. XLX. That will write the Excel file in our directory, and we will also write the Parquet file. So these two functions are just generating these output files. Perfect. We'll run that. So let's see what the issue is. Okay, so we need to install something quickly. Let me open up terminal. So we need a program, that's what that's telling us, in order to write the file we need. So here we have our terminal open. I'm going to make it a little bit bigger. Seems to be getting worse. So we are going to activate our local environment. Mamba activate basic data science environment. There we go. That's a little bit better. Excuse me. And then we are going to install Excel Writer. So we're going to see if we can use Mamba to install. So we're just installing a program that helps to write that file. And there it is. We go ahead and install it. Perfect. And then we are done with that terminal. We will go back to code, and now we should be able to write this with no problem. Perfect. And so now we have completed all the tasks on our list. We have this notebook that has performed all the changes we wanted it to perform. And the great thing about this is that we can reuse the code, that we can share this code when we publish or have it as part of our workflow, and we know exactly how we cleaned the data that we have. In fact, we should annotate some of this, which I'll do after the fact when we upload it to the GitHub repo. But let me show you the Excel file that we have. So let me show you the Excel file. Microsoft Excel. So this is the Excel file of the data we just cleaned. Let's see. And as you can see, it's far better organized than the previous file. It's cleaner. The titles or the column headings make much more sense. Just a better file to work with. And the authors did a great job collecting the data and organizing it to the extent that they could in Excel. But yeah, we just have a very nice data set, and this is the output from the script that we wrote, that we saved as an Excel. So this is fantastic. This can be shared with people down the line in analysis, and is easy to share as part of the study.